Hello everyone, welcome to another live session where we will deep dive into the beginner's roadmap for programming. And I know most of you all have a lot of questions and doubts regarding what programming language to choose and how to actually plan our programming journey. So to answer all of your questions, we have not one, two persons with us. One is Anshuman Singh, who is ex-lead engineer at Facebook and who was the part of building Messenger at Facebook, and also Kshitij sir, who is head of instructors, Scalar Academy, and now at Scalar School of Technology. And you will be answered all of the questions, like whatever you have, you can post it in the chat box, and Anshuman will take you towards the how to start your beginner's roadmap and everything. And whoever sticks to the until the end of the video, like until the end of the session, they will also get a free CS course. And over to you, Anshuman. And hi, Kshitij sir.
Thank you, Swaroop. Very quick introduction. My name is Anshuman. I also happen to be one of the founders here at Scalar. And as Swaroop mentioned, I was earlier the lead engineer who helped build Facebook Messenger and been running or like been contributing to tech education for the last 10 years or so. Now, we're going to break the session into two parts. First part is where we will talk about what is expected to happen in the ecosystem in the next 10 years, 15 years, what kind of jobs would be created, hence what kind of skills might be important. And then second part is where I have Kshitij with me. Kshitij will very soon introduce himself, but Kshitij has himself been a lead engineer at Snapdeal and then at Scalar, and he is today the highest rated teacher at Scalar. And all teachers at Scalar are really, really good. So if he has the highest ratings, then obviously, I mean, there is a reason for that. So let's start with part one, which is what is expected to happen in the next 10 years in the field of computer science, or in general, like what is going to happen, right? What is estimated is that if you are in India, I mean, I have some good news. What is estimated is that the GDP of India will grow from 3 trillion to roughly 10 to 15 trillion in the next 10 to 15 years. And because there is going to be massive growth in GDP, that means that a lot more people will earn a lot more money. And there will be creation of a lot more jobs that is expected in India, right? However, what is required for those jobs to be created? In the next 10 to 15 years, obviously, we cannot just directly start producing more agricultural crops. The amount of agricultural produce that we have is going to remain almost similar. Um, One of the key driving factors for this is going to be the fact that a lot of growth in the world is going to happen because of tech. What is estimated is that by in the next 15 years, almost every single household will have robots. There will be machines all around us. Everything that we use, everything all around us will become smart. Your clothes will become smarter. All devices that you use, they'll all become smart. And what is also estimated is that a lot of jobs that exist today, which are very repetitive in nature, they will get automated or semi-automated using code or using tech, which means it is possible that maybe the number of customer support folks that you have, that will reduce significantly in the future. But at the same time, there is a new kind of job that would be created. And all of these jobs would be all of you guys who would become future techies, future computer science engineers, who will create these kind of systems for the world, not just for India, for the world. India has does not have, a lot of natural resources. India does not have a lot of agriculture, but one thing India has a lot of is people, and very talented people. As long as the talent moves in the right direction, we will be able to grow in these fashion. Hence, it is important to understand and truly be skilled in tech, because if you are that, then you can create things for the world. If you just study computer science to pass exams, then you won't be able to create anything just for India also. So hence, the purpose of today's session is to take you through what matters in computer science. The one thing in computer science you will notice is that there are a lot of new technologies, in fact, new advancements that keep happening every day. And as such, can you go and learn every single new tech? I mean, for example, so much is changing in AI and machine learning today. No, nobody can. Then what is the secret sauce to becoming a good computer science engineer? In fact, that is what we will discuss in a lot of detail today. That is what Kshitij will take you through. And in fact, like Kshitij has a few examples prepared, few exercises he will do with you today, which will help you understand what then you should learn. The answer, however, the short answer is, at the end of the day, having very strong foundations and fundamentals is the most important thing, so that you can learn any new thing that is coming very, very quickly. And what those fundamentals are, how to go about learning those fundamentals, that is the piece that Kshitij will spend time on. Um, so let me summarize. Good news, lot of new jobs will be created. There will be a lot of growth in GDP. A lot of people will become rich. Bad news, a lot of mundane jobs will be replaced. A lot of repetitive jobs will be replaced. Hence, the only way this growth can happen is if the one thing that we are very good at, which is having a lot of people, if all of those people become skilled, especially in tech. And with that, I will pass it over to Kshitij. Kshitij, why don't you introduce yourself and maybe take us through this journey of helping us understand what foundations, what fundamentals are super critical and why are they critical? How are they being used in the real world today?
Thank you, Anshuman, for setting the context. Am I audible to all of you?
Yes.
Can you all give a quick thumbs up if I'm audible? Okay, awesome. So, guys, my name is Kshitij. I am the head of instructors at Scalar School of Technology. I graduated from Triple IT Hyderabad in 2015, after which I joined Snapdeal as a software developer. Then I joined InterviewBit, which later became Scalar as the lead software developer. And I have been teaching from past, I guess, 4 to 5 years. So, I can see a lot of you here are interested in knowing about what should be the initial things which you should spend time on if you want to become an impactful software developer, right? And so let's start with what exactly are the skills which you would be needing, and what are the skills which you need to master even in this ever changing landscape of computer science. What are the things which will always remain constant and you need to master them if you want to become an impactful developer? Okay, so there are two things. One is a tech or a technology, language, framework, databases through which you will be communicating with the computer. Another thing is your problem solving skills. So probably I will share my iPad screen and let me know if my screen is visible. uh yes, so everyone, is my screen visible?
Yes, sir, it is visible.
Great. So in computer science, in the end, what we are going to do is we are going to build some softwares, we are going to build systems which are going to solve some real world problems for us, right? You can explore all the applications that you have installed in your phone. You can see all the websites that you are using on a daily basis. All of these are systems which are solving some problem for you, some real world problem for you, right? For example, you might be using Facebook, you might be using Instagram, you might be using other form of social medias, and they're solving a problem of connecting people. You cannot physically go to each and every person and look into what is going on in their life. So you have social media for that. Similarly, you have Amazon, you have Flipkart, you have Mintra, you have other different type of e-commerce systems which are solving the problem of buying product without going to the shop physically,
right? They are providing you a step delivery of every single product within hours. Similarly, you have websites, you have applications which you use to book tickets. Nowadays, you don't need to go to the ticket window. You don't need to go to airport or railway stations. If you want to book a ticket, right, you can do that with just few clicks. So all of these applications that you are using, all of these websites that you are using, all of them are solving some real world problem. Now, in order to create an application, in order to become an engineer who can create these type of applications which can deliver impact on in the life of people, you need two things as a computer scientist. One, a technology. You need to know a tech using which you will be building the application, and another thing is problem solving skills. Okay. So computer science is not just about building things. You also have to build things using the resources in the most optimal way. And I will be talking about those resources and how to do that in detail in the later part of this discussion. So when we say tech, you need to know at least one language. When I say language, I don't mean Hindi, English, Tamil, Telugu, Gujarati, Marathi. I mean a computer language through which you can interact with a computer. So what exactly is a computer? Computer is nothing but a machine. You provide it instructions, it will process those instructions. To provide instructions to the computer, you need to know a language through which you can communicate with the computer, right? So you need to know at least one language. That language could be any language based on what you want to build, when you want to build, right? How many people are you going to serve through your application? But there are few things in every language which are common. If you know those things, if you know the basic constructs of a language, then you can transit to any other language in a very smooth fashion. So one language is required. After that, once you know a language, you need to know some frameworks. Frameworks means, so when you build large systems, there are a lot of moving pieces there. So as a developer, you are not going to build each and everything. There are few things which have already been built by people just to enable other developers build complicated products. So those softwares are known as frameworks. As a developer, you need to be good in one language, at least one framework, and you also need to know some database systems. Okay. Now, when we talk about languages, in every single language, there are multiple different things which are already there, and every new day there would be new things coming up. So you cannot learn a language in and out, at least at the initial time of your journey. If you're starting as a beginner, it won't be possible for you to learn a language with with the proficiency of your own natural language that you speak. You cannot learn a computer language with the proficiency with which you probably speak English, Hindi, or whatever is your mother tongue. So in the initial days, you have to focus on few language constructs which are going to be essential if you want to build larger systems. And as you keep growing in this journey, you can keep learning new and new things as required. So there are few things. If you're starting, you can choose any language. It can be C, C++, Java, Python, Golang, any language. But there are few things which are there in every single language which are essential to write codes, to understand codes, and to read codes. And these things are, first, you need to know what are data types. In every language, you will be dealing with some data, right? You will be having some numbers, you will be having some words, you will be processing some sentences. So all those things will be loaded to computer's memory in order to process them, in order to operate over them. They will be stored in some type of data type. Okay. Then you need to know some constructs which are known as control constructs or if else. If else means whenever you are writing a code, uh, let's take an example, right? So for example, if you go to an ATM, how do you think an ATM system is built? How do you think an ATM system is programmed? In an ATM system, when you insert your ATM, when you insert your ATM card, the first thing that the system detects is whether the card is a valid ATM card or not. If the card is valid, then do something, else do something else. You must have played games, right? Has everyone here played some games on computer, shooting games, probably PUBG or some other games, right? Mario, Super Mario, yes. So in those games as well, how do you think those games are being programmed? Someone has written the code for them, right? Which you are able to play. So in a game, there is again this small logic of if else, which decides whether your character is going to stay alive or whether your character is going to die. So if the bullet hits the heart or bullet hits the head of your character, then it dies, else something else happens. So these small constructs are going to be essential even if you are building a very large, very complicated game. If this, then this, else this. uh, if you guys watch Shark Tank, there was a startup which claimed to be an AI startup, and then one of the judges there found out that startup is not an AI startup. That is a purely if else based code. If else means if this, then this, else this, right? So if your condition satisfies, you do something, else if some other condition satisfies, you do something else if none of the conditions are satisfying, you do something else. So using only if and else, you can build systems which are very powerful, very complicated, and this is going to be the, you can say, most basic thing using which you can start developing applications which are useful for others. Okay. Then comes loops. Loops means, so why do we use computers? Do we use computers to only take decisions on these single questions like if this, then this? No, right? We use computers because of their speed, right? They can do things in a really, really fast way. Computers can solve thousands of millions of problems which a human is going to take, for which a human is going to take a day or probably a month. So we need computers for their speed, not for their decision making, right? We are the one who are going to decide what the computer is going to do, but we need it for their speed. So loops are the constructs which are provided in every single language, which allows you to leverage the speed of the computer. Loops are going to allow you to do the exact same thing again and again and again and again. For example, let's take a very, very simple example. If you want to print numbers from 1 to, let's say, 10,000, you don't need to write 10,000 different print statements, right? If you have seen or written any program, or even if you have not written, you can write something like this, right? For example, let's assume in some language, if this is the command to print a number, this prints 1, then similarly this prints 2, similarly this prints 3, and so on. If you know loops, you don't need to write all these 10,000 statements to print numbers from 1 to 10,000. You can do that in a loop, writing a single statement. So every programming language, since every programming language is a way to communicate with the computer, to make the computer do work on your behalf, every programming language is going to provide you language construct known as loops. Loops are going to give you the leverage to do something repeatedly, to make the computer do something again and again and again in the exact same fashion. If you have a logic, you can write the logic. The loop will execute it the number of times you have mentioned it. Okay. So these are three things which are essential in any language. Now, the language with which you start, it could be C, it could be C++, it could be Java, it could be Python, it could be any language. If you are good with these three things, if you know what are basic data types, if you can operate with basic data types of that specific language, if you can write logic using if and else, and if you can use loops to do something repeatedly, you are good to go. For example, let's say if you learned all these things using C or C++, Now your question is, if I have, let's say, spent 1 month learning these things in C and C++, tomorrow if I have to build code, if I have to build softwares using Java, will I be able to do that or not? Yes, you will be able to do that. It will hardly take you a week if you are good with C and C++. If you have a very good understanding of these three things, switching to another language is hardly going to take 1 week. In 1 week's time, you can switch to Java, or you can switch to Python, or you can switch to any other language of your choice or your need. There will still be few things which will be different, which will be completely different in the two languages. But as a beginner, you don't need to really worry about those things. Once you start building larger products, once you have really good hold on one language, then you will also understand what are the shortcomings of a specific language. You will yourself understand that, okay, this thing is probably not possible in this language. I need this type of feature, and hence I need to switch to a different language which can provide me this facility. So, as a beginner, do not have the tension of with which language you should start with. You can start with any language of your choice. For whichever language you are finding better resources, you can start with that. Programmers are supposed to be polyglots, which means they need to know multiple different languages. So even if you are starting with a language, in future you will have to switch to a different language, because this field of computer science is ever evolving and ever changing, right? After 6 months, after 1 year, probably we will have a new language and we'll have to use that new language. However, the basics are going to remain the same in every language. These three things are always going to be there. Okay. So regardless of which language you start with, you have to be good with these three things. If you're good with these three things, you can switch to a different language whenever needed. Then comes frameworks. Now, as a beginner, probably frameworks and database systems, these are not required. As a beginner, you should completely focus on learning these things, and probably the other part, which is problem solving. However, just to give you an outline of the journey of a computer engineer, after learning a language, after getting a good hold on the language, the programmer needs to know various different tools, various different technologies using which they can build complicated systems, right? So frameworks, if you have heard, probably Spring Boot, or you have Mern Stack. If you have heard these things, right? Rails, all these are nothing but frameworks. You know one language, then to build complicated systems, there are a lot of things which you will not have to do, which you will not have to write in your software, because people have already written code for that, and that code will make your life easy, and that code is known as framework. Okay, there is already a lot of things which has been pre-written. You just write your code, write it in the correct way, and your system will start working. Then probably frameworks is something which as a beginner you can ignore right now. But understanding database systems, this is going to be important and interesting as well. Has everyone here used websites like Facebook, Instagram, or any social media application? Yes. Okay. So, for example, let's say you go to your own profile page, right? Now you open facebook.com. Where do you think Facebook has stored all your data? Where do you think your profile picture is stored? Where do you think your profile details are stored? Where do you think your status or whatever you're posting, all of those things are stored? All of these things are stored somewhere, right? Because wherever, no matter from where you open Facebook, you probably might be opening it from your own system, probably you might be opening it from your college, from your school, from a different city, from a different country. Regardless of that, all your data will still get loaded to your page, right? Is it loaded in cloud? So there is a very interesting video. If you guys want to watch, you can watch after this podcast. cloud computing. This data is not stored in literal clouds. This is stored in servers, which are known as clouds, right? So servers are nothing but computers, right? CPUs. So in layman terms, there are computers which are stored in far locations. Probably some computers are stored in USA. Probably it is possible that some computers are stored in Bangalore, which are storing all this data for you. And when you type facebook.com in your browser and when you log in, then this data gets loaded from this faraway server to your computer through the internet. Okay, and this server which is kept far away is known as the cloud server. Okay, cloud does not mean cloud. Okay, so your data gets loaded here, right? Now, how exactly that data is stored in this computer? This, you can imagine your own computer, your own laptop to be this cloud server. How do you think this is stored in such a way that whenever you open Facebook, it gets loaded immediately? Right? Similarly, whenever you are scrolling through Instagram, it will show you various different posts with their likes, with their comments instantly, and you can keep scrolling it. The feed will never stop. So to store data in an effective way, programmers need to know about database systems. Right? Database systems will help you store data in a persistent way, which will ensure that your data is not getting lost. If you have added any status, if you have added any photo in Instagram, when you open it next time, it is still there, it is not getting lost. The safety is being maintained, your data is secured, right? Other than you, no one else is able to edit your details in Facebook unless they have your credentials. Other than you, no one else is able to delete photos from your Instagram account or add new photos from your account unless they have your credential. So all those things are maintained by your database systems. Okay, so these are few things which as a programmer you need to know, and these are the basics. As a beginner, if you know basics about these things, great. As a good developer also, these are the things using which you can build complicated applications like Facebook. If you know these things, that should be sufficient apart from problem solving. Okay, now let's imagine if you are someone who knows a language. Okay, let's say you know a language which is Java. You are an expert in this language, plus you also know a framework. Okay, let's say you know something known as Spring, which is a framework for Java, and you also know a database system. You are an expert in all these things. Okay, will you be able to build a system as complicated as Facebook or Amazon? Will it be possible for you to build a system as complicated as Facebook or Amazon if you're an expert on these three things? No. Okay, why do you think no? Why is the answer yes? You would also need to know some front-end technologies, like let's take the most basic thing, HTML, CSS, JavaScript. That also you would not need to know. However, more important thing is problem solving. Only knowing the technology, only knowing the frameworks, only knowing the database systems, only knowing HTML, CSS, JavaScript, that is not sufficient to be a good engineer. More important thing about being a good software engineer is the skill of problem solving. Let us try to understand this using an example. Okay, let's take an example. So has everyone here used Amazon? Yes. Can I assume all of you have used Amazon? Excellent. Now, in Amazon, whenever If you want to open Amazon, what do? You go to your browser and you type amazon.com, right? Or amazon.in. It will automatically redirect you to amazon.in if you are in India. Has it ever happened with you that you type amazon.com, press enter, your internet connection is working fine, and the amazon.com page does not open? Has it ever happened with you that the Amazon page is not opening? It throws some error. It is showing you 404, page not found, or it is showing you 500, some type of error. It would never, right? Even if it happens, it would probably happen once in a year, or probably once in 2 years or 3 years, right? So systems like Amazon, systems as robust as Amazon, they are built in such a way that they are always and always available. Be it Amazon, be it Google. Google goes down for a minute and it becomes a news, right? It is suddenly you will see a lot of very recently Azure servers of Microsoft, they went down and it was a big news, right? So these systems are so robust that regardless of how many people are using them, regardless of people from how many locations are using them, whether you are in USA, whether you are in UK, whether you are in Paris watching the Olympics, whether you are in India attending this session, if you open Amazon, it will work. That is availability. The system is built in such a way that it is always and always available. This is a problem that a computer engineer has to solve. How to make the system in such a way that it is always and always available, regardless of how many people are trying to open it, regardless of from how many locations the system is being accessed, regardless of how much amount of data is being stored or being queried in the system, right? This is one problem. This is known as a high level design problem, where where you decide how many servers you need, where you decide what type of cache you need. But before that, before actually going into, as a software developer, before going into the availability problem, you would solve certain easier problems. For example, when you open amazon.com, let's discuss your journey as a user in Amazon. Okay, so you go to Amazon, then if you want to search for a product, what product you would be searching for? Any examples? iPhone. Okay, so if you want to search for, let's say, iPhone, the moment you can try this right away, the moment you write IPH, and it will start showing you a lot of suggestions, right? Be it iPhone, be it camera, be it anything. You would definitely not be searching for mango in Amazon, but if you're searching for iPhone, the moment you type IPH, you will start seeing suggestions, right? It will auto-complete what you want it to, what you want to convey to Amazon. It will show you iPhone, all types of iPhones. It will also show you category: iPhone in phones, iPhone 13 in phones, iPhone 15 in phones, iPhone covers in cover, right? It will show you all those things. This is again a problem. This is the autocomplete problem. Now tell me one thing. How many products do you think would be there in the database of Amazon? How many products would be there? 1,000, million, billion? Out of all those products, the moment you type IPH, it shows you the most relevant products. The most relevant products, right? You can try it right away. Whatever you want to buy, that will always appear in this autocomplete, that will always appear in this auto suggest. This is a problem which computer engineers are solving, right? Let's move on. Once you select one of these, right? Let's say you wanted iPhone 15 or 14, whatever is the latest, and you selected it and you pressed enter. This one was iPhone 15. You pressed enter here. The moment you do that, what would happen? Amazon is going to show you a lot of products, right? It will then fetch all these products and it will show you the most relevant products that you need. Has it ever happened with you that for buying anything from Amazon, you have to go to the second page of Amazon? No. Most of the times, your product would be present in the top 4 products. So you will be able to see some products, their prices, right, their colors, etc. And you can choose your product right from here. iPhone probably is a niche thing, right? Probably there won't be a lot of products with the name iPhone. Let's take something generic. Let us not flex about iPhone. Let us take something generic. Okay. So let's say if you type t-shirt, then also it will show you very relevant results. All the t-shirts will be shown. Out of all those billions of products, you have given it just few characters, and based on that it is able to fetch the exact same product which you want to buy. And not just that, after that, so after searching, the next step is sorting. First, it searches from billions of products. It will search for few of the products which you are interested in. Then it will provide you functionalities to sort. Has everyone used this thing? You can sort based on the ratings, you can sort based on the price, you can sort based on other different things, right? How exactly these things are happening, how exactly, what exactly is going on in the background when you press that button, what happens? Is there a solution to those things in these? No. Even if you know Java, even if you know all type of frameworks, even if you know the database, you probably won't be able to implement these things. These are problems for which you need really, really good problem solving skills. Correct? Then let's move ahead. What would happen? So let's say you pick one of the product from here, you press enter, you go to the payment section. However, in the inventory, there is only one item left. So therefore, there was, let's say, one seller from whom you are buying this iPhone or t-shirt, whatever, and there is only and only one item left in inventory. Okay. However, since millions of users are using this system, it is possible that at the same time, there are multiple users who are trying to buy the exact same product. It is possible, right? One item in the inventory, and there are 4, 5, or probably 10 users who are trying to buy the exact same product. This is a problem of concurrency. It would never happen that Amazon sell this product to all of them because there is only one piece remaining. So it will be sold to only one of them. However, everything is going to happen in parallel. You can try out a simple experiment with Book My Show. Has everyone used Book My Show? The exact same thing happens in Book My Show on a regular basis. You go to a movie, you select some seats, right? Probably, let's say this is the layout of a movie theater. This is the screen. Let's say you pick some seats here, and you can open another page in probably incognito, and you can try to book the exact same seats again. It would show you some error. It is not going to assign same seats to two different people. This is a problem of concurrency, which these software engineers are solving. Okay. So only learning a language, only learning a framework, only learning these systems is not sufficient. You need to be really, really good with problem solving. If you're not good with problem solving, if you cannot solve new problems, if you cannot solve real world problems, then you will soon be replaced by AI. Because all these things are now provided by AI as well. You can just ask ChatGPT to create an application for you, and it will do that. It can write fully working code for you, which can do something. But will it be able to solve problems or not? That is still doubtful. So, as far as what we can estimate right now, what we can see right now, problem solving is a skill which you need to master. Otherwise, tomorrow any AI system is going to replace the software engineer that you become. Okay. Okay, so this is not enough. You have solved the problem of concurrency. What next? After this, you make the payment. Payment has to be secure, right? So that is again a problem of cyber security, of network security, which the engineer has to solve. Then comes the delivery, the most complicated problem. Have you ever thought about this delivery thing? Can I assume all of you use Amazon or any other e-commerce system on a regular basis? Yes, all of you use it. Amazon gives you an estimated delivery date, right? You might be ordering from, let's say, Indore. The product is coming from Jalandhar. There are multiple modes of transports which would be changed between these two. And it's not just going to be a single product. There will be a bunch of products which will be coming from Jalandhar to Indore at multiple places. There would be multiple people who had placed orders from different localities of Indore, right? But Amazon will accurately estimate a delivery date, give it to you, and exactly at that time, at that mentioned date, you will get your product. And not just you must have observed that if you're living in a society, you must have observed that when you get your Amazon product, there are a bunch of other people in your neighborhood, they also get their Amazon product. Why? Because Amazon wants to optimize the usage of their resources. They don't want to deliver these items to single to people in single basis, right? They want to optimize the usage of their resources. So that is why they do these deliveries in bulk. How exactly is this being done? Is there someone who is sitting and then creating these batches? Is there someone who is manually checking all the orders? Are there people who are deciding which product should be delivered on which day? No, everything is automated. There are algorithms which have been built by software engineers who automate this complete process. All the all the deliveries of a specific location are batched together. What should be the route? What should be what should be the mode of transport? How many different mode of transport should be used? What should be the route of the delivery guy who is the end person who delivers you at your doorstep? All of these things are automated. None of these are done manually, and this is probably the most complicated problem which Amazon solves, and it solves it beautifully. Now, in probably in other cities, the complexity could be slightly lesser. If you talk about cities like Bangalore, is there anyone who's currently staying in Bangalore? In Bangalore, it is possible that if your Amazon delivery guy is standing here, delivering the order probably at a distance of 5 kilometers takes lesser time, but delivering the order right across the road takes more time because of the traffic. It is possible that to go here, the delivery guy has to take a very long U-turn and come back, which is more than this 5 kilometers. So a lot of various variables are there. There is distance, there is road availability, there is vehicle availability, there is the size of vehicle, there is traffic, there is weather, there are various different conditions, there are various different variables available, including all of them in the algorithm. Amazon gives you a delivery date and a delivery time, and you get your parcel at the exact same date at the exact same time. That is the beauty of problem solving. Okay. Is everyone clear till this point? So again, giving a quick recap. If you want to become a good if you want to become a good software developer, if you want to start your journey as a software developer, you need to be good with at least one language. As a beginner, start learning one language. Then once you become proficient in a language, then you can learn about what are frameworks. If you don't understand what are frameworks as of now, don't worry, leave it. Right, this is something that will come into picture when you are proficient with one of the languages, and then this will come even later in your journey. But one skill which you should start mastering as of now is problem solving, because this is something which will take time for you to master. You can learn frameworks and databases within a month. Problem solving is not something that you can learn in a month. Right? This is something which will need time, which will need a lot of practice, and this is the skill where a lot of engineers, they spend most of their time. So let us now discuss about what will it take for you to become a good problem solver. You guys want to know that? How can you become a good problem solver so that even you can develop products like these? Okay. So for that, the most basic thing that you need to learn is the power of observations. Can I assume all of you have learned maths in your 11th, 12th, 10th class? All of you have done maths. What do we learn in maths? What exactly we do in maths? So in maths, we get problems, right? If I give you a problem which you have not studied as of now, if I give a calculus problem to a class 8 student, will they be able to solve it? Probably not. If they have not studied what is calculus, they won't be able to solve it, right? They need to explore different dimensions of problem solving. So there is trigonometry. If you know trigonometry and I give you a problem where there is a cliff, there is an angle, you have to find the height of the cliff, you would be able to do that. If I give you a calculus problem after teaching you calculus, you will be able to do that. But you will only be able to do that if you have practiced sufficient amount of problems of that genre, right? Just by knowing trigonometry, you probably won't be able to solve a trigonometry problem. You need to practice. So two things are important. One, you need to explore what all type of problems can be there. Second, you need to practice different type of problems. Right? Problem solving is nothing but pattern matching. What is pattern matching? So in computer science, in machine learning, if you want to identify, if you want to write a code which can identify whether a given picture is a face or not, right? You must be having in your cameras a system which identifies that this is a face. That is pattern matching. How is pattern matching done? You feed a lot of data to it. You feed a lot of data and you tell it that this is a face, this is a face, this is a face. When the algorithm matches a new picture with whatever it has in its database, it matches certain features, and based on that, it claims that this new picture is also a frame or also a face. In the exact same way, you can master problem solving. There are limited set of problem types or genres. If you visit all of them, if you practice all of them, you will be able to master the skill of problem solving. However, the most important skill there is observation. You will have to, even after you have gone through all type of problems, you still have to classify the new problem, right? You still have to tell whether this new problem is a calculus problem, or whether it is a trigonometry problem, or whether it is some other type of problem, right? You still need to do that pattern matching. Let us talk about this skill of making observations. So how many of you know about a person called Gauss? You guys know about a person whose name was Carl Friedrich Gauss. the person who gave Gauss theorem, right? So you must have studied, you must have read this story as well, that in one of his class, the teacher was not uh, having was not feeling well, so the teacher just gave a problem to keep the class busy. Teacher did not wanted to teach, so the teacher gave them a problem just to keep them busy. And the problem was that these students who were third or fourth grade students, these fourth grade students had to find the summation of all the numbers from 1 to 100. The teacher believed that all of these students, they will go on adding all of these numbers. It will at least take an hour and all of them will be busy. The teacher said that any student who gives me the sum of this series is going to get a chocolate from me. The moment all the students got the problem and the reward that they are going to get, all of them started adding these terms one by one. However, there was one person, Carl Friedrich Gauss, who made observations, who made useful observations. He observed that if I write this series, right, this series is just 1, 2, 3, 4, 5, and so on. Now, interesting thing about this series is that if I add 1 and 100, I get 101. If I add 2 and 99, what is the answer? It is still 101. If I add 3 and 98, it is still 101. So if I pick one term from front, one term from end, I get 101. Which means if I write the same series once again in reverse order, all of these terms are going to add up to 101. Small observation, but very powerful observation. Then you add, this is 2 times the summation of the series, and we are getting 101 how many times? 100 times, right? And then you get 2s is equals to 100 times 101, which means the summation of the series is going to be 101, sorry, 100 times 101 divided by 2, which comes out to be 5050. Within minutes, the person was able to get the summation. And this is the guy who invented the formula which you guys are writing in the chat. This was the guy who came up with what we know as arithmetic progression, and he gave the formula of all of these things. So the thing to note here is the observation. Fourth grade student made such an interesting observation, and if you're able to make these type of observations, then you have the potential to become a really, really good problem solver. So this was just to build the context. Let us take an example in the context of computer science. Okay. Let us take an example in the context of computer science. So do all of you know what are prime numbers? Can I assume all of you know prime numbers? Yes. Okay, great. So prime numbers are those numbers which have exactly two factors. Positive numbers, right? Positive integers with exactly two factors. So by this definition, what is the smallest prime number? It is 2, not 1, right? 1 is neither prime nor composite, remember that. So these are our prime numbers: 2, 3, 5, 7, 11, 13, 17, and so on. Now, prime numbers are very, very important in computer science, right? There are a lot of algorithms, there are a lot of systems, especially these systems which build network security, which build encryption. They are based on prime numbers. And you will learn about the importance of prime numbers in future when you become a software developer. So it is also equally important to identify whether a given number is a prime number or not. If I give you a number and if I ask you whether this number is prime number or not, can all of you do that? I believe you all can do using this definition. Right? You will just count how many factors the number has, and if the count of factors come out to be 2, including the number and 1, then you can say that yes, this is a prime number. Otherwise, you can say that this is a composite number. Now, if you want the computer to do the exact same thing, you will have to write a program. So the set of instructions which you will be giving the computer to check whether a number is prime number or not, that set of instruction will be known as a program. Okay. So if you are given a number n, given a number n means you can be given any number. Any number can be given as the input. Your program, your software should tell whether this number is prime or not. As simple as that. Okay. Now, what do you think uh, you would want the computer to check if you want to check whether the number is prime or not? What exactly are you going to check? If if else, yes, you will be using if else, but how? The question is, how exactly are you going to use if else? So you will have to check for every number which is smaller than n. You will check how many of those numbers divide n, right? For example, if the value of n is 10, we can check how many numbers from 1 to 10 divides n. If the count is 2, number is prime, otherwise the number is not prime. Or we know that prime number definitely is going to have a divisor which is 1 and a divisor which is the number itself. So instead of going from 1 to 10, you can go from 2 to 9. If there is even a single number that divides this, then this number is not prime. Correct? Do all of you get this? So in computers, we'll be using the concept of loop because we have to check the same thing again and again and again, right? So in basic logic, what we need is, we need if any number from 2 to n minus 1 divides n, then n is not prime. Else n is prime. So this is our logic. If any number from 2 to n minus 1 divides n, n is not prime. Otherwise, n is prime. Correct? But you have to check n with multiple different numbers. So doing the same thing again and again and again means loops, right? So what we can do is, using loops, we can do this thing. We can write code for this and we can check for all the numbers. So we can say for every I in the range from 2 to n minus 1, if I divides n, then n is not prime, right? This means not prime, correct? If all of these i's, if all of these numbers in the range from 2 to n minus 1 are not able to divide n, then that means n is prime. This is simple logic. Let's take an example to understand it in a much better way. So what we are saying is, if the value of n, let's say, is 10, we are going to check with every number starting from 2 till 9. If there is even a single number which divides 10, then 10 is not prime. So we check with 2. Does 2 divide 10? Does 2 divide 10? Yes, 2 divides 10, right? 10 is an even number. 2 divides 10. That means 10 is not prime. Let's take another example. If the value of n is, let's say, 11. If the value of n is 11, we are checking all the values from 2 to 10. Does 2 divides 11? No. Does 3 divide 11? No. 4? No. 5? No. 6? No. 7? No. 8? No. 9? No. 10? No. All the numbers from 2 to 10 do not divide 11, which means 11 is a prime number. Clear? If the value of n is 101, what will we do? We will check with every number starting from 2 till 100. Does 2 divide 101? No. 3 divides 101? No. 4 divides? No. Till 100, all these numbers do not divide 101. That means even 101 is a prime number. So this is the basic logic which can be implemented very easily using a construct known as loop. Okay, since most of you do not know what are loops, how to write code in any programming language, hence we are skipping the code part, but this can be implemented very, very easily using the concept of loop. However, in order to build this problem solving skills, this part is still not important. Even if you don't know what are loops, even if you don't know how to write this code using loops, still you can understand the beauty of problem solving here. Okay, so I want response from all of you now. If you are checking for 101, exactly with how many numbers did you check it? How many times are you going to execute this statement if I divides n in case of 101? From 2 to 100, how many numbers are we checking? 99. Correct. For 11, how many numbers are we checking? From 2 to 10. 9 numbers. If the number is large, right? If let us say the number is 10 raised to power 5, how many times we will have to check? How many times are we going to divide this number and check whether it is divisible or not? Almost these many times, right? This is going to be 10 to power 5 minus 2, which is equal to 10 to power 5 approximately. Whatever is the number, that minus 2 times, because we are not checking with 1, we are not checking with n itself. Remaining with all the numbers we'll have to check. Now, when we say problem solving, we are actually trying to optimize the usage of resources. Can anyone tell me what exactly do we need by resources in terms of computers? Problem solving is just optimizing the usage resources. What are the resources in terms of problem solving? In terms of computer science, is it land? Is it clothes? Is it food? What type of resources are we talking about here? What is it that you want to optimize when you're writing programs and when you're creating softwares, when you're creating websites, when you're creating applications? You want to optimize time and space. Space means the memory of your computer, right? So you want to optimize. When we say resources, that means time and space. Your computer devices, your laptop, your desktop, your smartphone, your smartwatch, your washing machine, all these are computers, right? All these have some limited amount of memory. When you buy a computer, you check what is the memory, right? What is the RAM size? What is the hard disk size? So you check that storage. And you need these applications to work as fast as possible. So that is time. Imagine if you go to Facebook and you upload an image and it takes 30 minutes for that image to get uploaded. Will you come back and use Facebook again? Probably not, right? You would say that it takes an eternity to upload my data there. I won't be using it. If you go to Instagram and let's say Instagram takes fractions of second for your image to be there in your account, you will be using Instagram. So you want your applications, your softwares to be as fast as possible and to consume as less memory as possible. Okay, so that is what we want to optimize for. Now let us come here. When we say that we are checking whether this number divides n or not, this is an operation which is being done inside the computer. This is going to take certain amount of time, right? For us, computer does a lot of things in a blink of eye, but internally it is taking some time, some fraction of second is being taken. Do you guys understand that? Every operation that you are performing in the computer is going to take some amount of time, right? Some fixed amount of time. So we can assume, looking at the computing power of the computers that we use in our day-to-day life, we can assume that uh, 10 raised to power 8 such checks, whether a number is divisible by another number or not, 10 raised to power such checks can be done in 1 second. Computers are extremely fast, lightning fast, right? As a human, it will take years for you to keep dividing a number by these many elements, by these many different numbers. But a computer can do this in 1 single second, lightning fast. But is it fast enough? That is the question. So if you want to check whether a number as large as 10 raised to power 8, of the order of 10 raised to power 8, is prime or not, your computer is going to take, your program, your logic that you have built is going to take 1 second, right? However, how much time will it take for a number as large as 10 raised to power 9? If you have to check whether a number as large as 10 to the power 9, 10 to the power 9 plus 1, 10 to the power 9 plus 7, and so on, if these numbers are prime or not, how much time is it going to take? It's going to take approximately 10 seconds. Is this a small time? No. Now, with respect to computers, 10 seconds is too much. If your program is taking 10 seconds just to check whether a number is prime or not, it is not optimal. You are taking too much time to do this simple operation. Okay, what would happen if the value of n is 10 raised to power 18? How much time is it going to take? If the value of n is 10 raised to power 18, this is going to take how much time? 1 day. Just 1 day. 10 raised to power 9 is being checked in 10 seconds. 10 raised to power 18, it is not 10 raised to power 10. 10 raised to power 10 will take 100 seconds. 10 raised to power 11 will take 1000 seconds. Okay, let's do this step by step. Let's not directly move to 10 raised to power 18. If you have a number as large as 10 raised to power 10, this will take you 100 seconds, which is more than a minute. If you have a number as large as 10 raised to power 11, this is going to take you 1000 seconds. Now just apply unitary method and tell me how much time would it take if the number is as large as 10 raised to power 18. This is going to take 10 raised to power 10 seconds. 10 raised to power 10 seconds. Is this a number small or large? What is 10 raised to power 10 seconds? We are not programmed. We are not built. We are not accustomed to see these many seconds, right? We don't process these many seconds. We process seconds in 30, 40, 50, 60, 120. This is a very, very large number. So can anyone try to convert this from second to hours or minutes or days? How many hours is this? This is too many hours. Okay, can you guys try to convert it to days? How many days is this? 1,15,740 days. Even that is too much for us to process, right? We are not programmed to process those many days. Can anyone convert this to years? Correct. This would come out to be 300 approximately and 17 years. Now imagine you have written a simple logic, simple code which takes a number, checks whether the number is prime or not. How much time will it take for your code to identify whether a number as large as 10 to the power 18 is prime or not? It is going to take 317 years. Is this time small or large? So probably this is what is going to happen. You have written this code, you run this code, you will have kids, you will graduate out of Scalar Academy, you will become computer scientist. Code is still running. Then your kids will be there, they will check whether the code is running or not, right? Then they will also probably graduate out of Scalar school of technology, and then you will have your grandkids. Then you will have your fourth generation. What all could have happened in these many years? It is possible. There is a fraction of chances that within this time, RCB has won IPL. It is possible, right? A lot of things would have happened. Probably humans have settled in Mars. We have some of our people living in Mars, but your code is still trying to identify whether the number is prime or not. So that is the impact of writing a code which is not optimal, right? As of now, even if you know Java, you know any language, you know any framework, you know HTML, CSS, JavaScript, or any other technology, none of them are sufficient enough to optimize this time period which this code is taking to solve a simple problem, extremely simple problem, right? That being said, if you are good in making observations, simple and useful observations, you can, without changing the computing power, without adding more computers, you can optimize this to be done within seconds. Let us make some observations. Okay. So we need to check whether a number is prime or not, for which what we are doing is we are checking for every number from 2 to n minus 1. If the number divides the given number, it is not prime, else it is prime. Let's take an example. Let's say we have n equals to 24. What exactly are we doing? We are checking whether uh, whether n is divisible by 2 or not, right? Then we are checking whether it is divisible by 3 or not, then 4 or not, 5 or not, and so on. In case of 24, it is divisible by 2, so we will stop there. In case of 101, we will not stop because until 100, we won't be able to find any number which is able to divide it. Okay. Now, interesting thing about division is that whenever you divide a number n by a number a, if n is divisible, you will be getting an integer as the quotient, right? You will always be getting if it is divisible, then the answer is going to be an integer, and that is why you can say that a into b is going to be equals to n, correct? For example, in case of 24, if 4 divides 24, n by 4, which is 6, also divides 24, correct? So we can say if a is a factor of n, if a is a factor of n, n by a is also a factor of n. Does this make sense to all of you? Simple observation. Factors will always and always occur in pairs. Factors will never occur alone. If you have 4 which divides 24, 6 also divides 24. If you have 3 that divides 24, then 8, which is 24 by 3, also divides 24. Correct? If you have 6 which divides 24, 4 which is 24 by 6 also divides 24. Factors are always and always going to be in pairs. Which means after a certain value of I, the pair should start repeating. Let's make an observation to make it even more clear. If I write down I here and the pair which is 24 by I on the other side, what is the pair of 2? 24 by 2, which is 12, right? If 2 divides 24, 12 will also divide. We don't need to check whether 12 divides or not. It will divide because of this relation. You can bring B here, bring A here. It will divide. Then if 3 is a factor, then 24 by 3, which is 8, is also a factor. Then if 4 is a factor, 6 is also a factor. 5 is not a factor, we can remove it. What is the next factor of 24? The next factor of 24 after 4 is 6. What is the pair? It is 4. Have we already identified these two numbers as factor? Yes, we have. We have already checked 4. We have already identified 6 as a factor. So we don't need to go after this. Let's do the exact same thing for 100 as well. If n is 100, let us list down factors and their pairs. Does 1 divides 100? Yes, 100 will also divide 100. If 2 divides 100, 50 will also divide 100. If 4 divides 100, 25 will also divide. If 5 divides 100, then 20 will also divide. If 10 divides 100, 100 by 10 is also 10. 10 also divides. After that, after this, the factors will start repeating. The next factor after 10 is 20, which has already been identified. Next factor is 25. We already have it. Then 50, then 100. So if you want to get all the factors of a number, you don't need to iterate till that number. You can stop here. The moment the two factors become equal, then you know that after this, the factors will start repeating. Correct? Let us take one last example. If you have n equals to, let's say, 16, we'll write I and 16 by I, which is n by I. So 1 divides 16, 16 also divides 16. 2 divides, then 8 will also divide. If 4 divides, 4 will also divide. Then after this, the factors will start repeating. The next factor is going to be 8. After that, the next factor is going to be 16. So the moment the two factors become equal, after that, the factors will start repeating. Is that making sense to all of you? Correct? Which means to check if, or we can say that any factor after this line will only exist if there is a factor before this line. If you don't have a factor before this line, after this line also there won't be a factor, because these are going to appear in pair with these, right? If you have anything before this line, only then you can have anything after this line. Now, in case of 24, the two factors don't become equal. So what is the condition? What do you think is the condition after which the factors will start start repeating? Can I say that this has to be less than or equals to this? Till the number with which you are checking is less than or equals to the pair, till that you are going to get new factors. The moment these two become equal, or the moment this becomes greater than this, the factors will start repeating, right? So you can see that here 6 has become greater than 4, right? We can take probably a few more examples. Let's take an example of 18. For 18, let's see when exactly the factors start repeating. You have 1, 18, then 2, 9, 3, 6. After this, 4 does not divide, 5 does not divide, then you get 6 again. So the line is drawn when the first factor is small. After this, you are going to get 6, 9, and 18. So we can say that I should be less than or equals to n by I. This is the point. After this, the factors will start repeating. Okay. So what we are claiming through this observation is that factors are always appearing in pair. If there exists a factor before this line, then there will definitely be a factor after this line. If there is no factor before this line, there will not be any factor after this line, which means we don't need to go till the number itself. We only need to go till this line. What exactly is the position of this line? How do we know that we have hit this line? We have crossed this line. We have this equation. I should always be less than or equals to n by I, which means I square should be less than or equals to n, which brings us to a conclusion which one of you was putting in chat right from the start. I should be less than or equals to square root of n. You don't need to go till the number n. You can stop the moment you hit square root of n. If you hit square root of n, you have not found any factor. There is no way you can find any factor after this as well. Let us try for 121 as well. In popular demand, let's try n 121. So you have I, you have n by I. Does 1 divides? Yes. Does 2 divide? No. Does 3 divide? No. 4, 5, 6, 7, 8? No. What is the next number that is going to divide 121? Anyone? Correct. It is going to be 11. What is the pair? If 11 divides, what is n by 11? It is also 11. That's it. This is your line. After this, the factors will repeat. What is the next factor that we are going to get? It is going to be 121. So factors will repeat right after the square root of the number. 11 is the square root of 121, right? Here you can see 4 is the square root of 16. 10 is the square root of 100. 4 point something is the square root of 24. So for the numbers which are perfect square, we will find a factor which is perfect square root. The numbers which are not perfect square, for them we will find a line in between. We'll find 4 point something is going to be the square root. So we have a line here. Right after this, the factors will start repeating. So concluding again, we don't need to go till the number itself. We don't need to go till n minus 1. We only need to go till square root of n. Let us do the same thing once again. Do all of you remember our initial assumptions? Our current state computers can perform 10 raised to power 8 such checks in 1 second. Okay. If the value is 10 raised to power 8, how many checks do we need to do? If the value is as large as 10 raised to power 8, we are not going to check with all 10 raised to power 8 numbers, right? This times we are only going to check for square root of n. What is the square root of 10 raised to power n? 10 raised to power 8. What is square root of 10 raised to power 8? 10 raised to power 4, right? So this is going to give us 10 raised to power 4 operations. And if in 1 second we can do, or in 10 raised to power 8 iterations can be done in 1 second, how much time will it take to do these many operations? This divided by this, which is what? Which is 10 raised to power minus 4 seconds. What is 10 raised to power minus 4 seconds? We'll check for 18 as well. But what is 10 raised to power minus? This is fraction of second, right? Something which was initially taking 1 second is now taking very small amount of time. Correct? What about 10 raised to power 18? If n is as large as 10 raised to power 18, how many operations we need to do? Ten raised to power 8 in 10 raised to power 8 in 1 second, 10 raised to power 9 in 10 seconds, 10 raised to power 10 in 100 seconds, and so on. Okay. So 10 raised to power 18, how many operations are required? 10 raised to square root of 10 raised to power 18. What is square root of 10 raised to power 18? Square root of 10 raised to power 18 is 10 raised to power 9. These many operations are required. And what is the time required to do these many iterations? 10 raised to power 9 operations. We have already seen that, right? 10 raised to power 9 operations needs 10 seconds. Which means that something that initially needed 317 years, not 317 seconds or minutes or hours or days, 317 years, that can be optimized to just 10 seconds by making a very small and very basic mathematical observation. Does that make sense to everyone? This is the power, this is the beauty of problem solving. And this is the most needed skill. This is the skill that makes you a developer, which can build softwares, which can build systems that can create impact on the world level. Does that make sense? Super. So now the question is, how will you become so good in problem solving? How can you become uh, how can you sharpen your problem solving skills? What are the things that you should practice, or what is the structure of the course which you should be following? So for that, you should definitely start with the basics first. Since you are not going to solve problems which are generic in nature, you will be solving problems specific to computer science, right? You'll be solving problems using your code, using your system. So you should start with learning a language. Which language you should choose? You can choose any language. If you can learn, if you can start with Java, nothing better than that. But if you have already started learning a language, you can start with that. Okay, start with language and do some practice of problem solving. So the way we have crafted the curriculum in Scalar reflects what we have been discussing in this session. In SST's curriculum, in the first 3 months, we will be building your base, right? So we have selected Java as the language because Java is one of the most widely used language across industry. A lot of big systems, useful systems which we use in our day-to-day life are built using Java. Java is also good for scalability, making your system more available. So, but you can start with any language. As I said earlier, you can pick any language and you can start learning it. So start with learning a language, and that is what we have done. Then you should be learning some concepts of maths, which are really, really required, which will really help you optimize your code in future, and which will build this problem solving skill for you. Not all concepts of maths are required. Calculus, trigonometry will be very rarely used. Most of the time, something known as a discrete maths will be used. Discrete math and number theory. So if you have given the NSCT test, these are the topics that we also test in NSCT, right? How much you already know these topics. So these are the topics which will be taught to you in the math syllabus. And then since you also need to start building things, right? You need two things. You need problem solving skills, plus you also need a way so that you can implement those skills and you can convert that to a system that is solving some problem. For that, we will start with web development, which will initially start with HTML, CSS, basic JavaScript, and then later on it will develop into it will teach you frameworks, and then later on you will learn database systems. You will design schemas for systems like Netflix, Facebook, Amazon, and you will be building these systems as well. Okay, so the way we have structured the syllabus is, first you learn the basics, which is language, basic maths, basic web development. Then you dive deeper into the skill of problem solving. And when we say problem solving with respect to computer science, there are two things which are extremely important. One is known as data structures, and the other is algorithm. Now, what are data structures? What are algorithms? If you want to know about them, we have already created a video about how to start, how beginners should start learning data structures and algorithms. You can find it in the SST's YouTube channel. It is already there. But these are the skills which you will be taught in SST in depth. Most of the time will be spent sharpening these skills, and these are things which will also be asked to you in interviews. Companies like Amazon, companies like Google, Facebook, all big tech companies, and some startups as well, are going to test your problem solving skills through the knowledge of data structures and algorithms. So this is going to take majority of your time in Scalar School of Technology in your first half of the syllabus. Then later on in the course, you will also be learning about databases in depth and computer science fundamentals. Computer science fundamentals means what is operating system, how exactly is your operating system able to do all these things at once, how are all these applications running in your or in your system, right? How are things being loaded in your memory? What are the specs that you should be looking for if you want to perform a specific task in your system, right? So all those things will come under computer science fundamentals. And with this, since we are also going to learn a lot of there is so much of advancement in the area of artificial intelligence and machine learning, we will also be building the base for that. So in future it is possible that almost all the jobs need experience and expertise in the field of artificial intelligence and machine learning. So for that, the most important thing which a lot of people ignore completely is the maths behind it. You need to be really good with probability and statistics and linear algebra. You can say this is the base of data science and machine learning. If you don't know this, you can only use already available data science models, but you cannot build something on your own. You cannot become that impactful developer who can create softwares that can create impact in the world. So you need to be really good with these topics of math. So that is why before moving into actual ML algorithms, we will be making sure that you are good with these basic concepts which will be required to understand data science and machine learning, after which we will be moving on to machine learning algorithms. So after you're done with this, then we'll have ML algorithms in course, and then we can also have data analytics in our course as well. Then you will go for a year-long internship. After this there will be an year-long internship. So this is basically all the things that you need to know to start working as a software developer. Once this is done, once you have the base of a software developer, you are good with problem solving, you can build systems on your own, you will be able to build a lot of projects during this tenure of 2 years, and you're also good with some ML algorithms and the math behind it, then you are ready to join the industry. You are ready to start working as as the junior software engineer, and then you will have a 1 year long internship, after which you will do your specialization. Now it is too early to learn about what is exactly going to happen in specialization, because for that you need a lot more context about what is going to happen here. But as a beginner, if you want to start, you can start with learning the languages and sharpening your problem solving skills. Okay. Now this is overview of what we are going to do in Scalar School of Technology. If you want to join SST, there is an offer. So there is a coupon code which will be shared with you here in chat, which you can see in the chat. If you use this code, then you get a discount of ₹500 directly in the initial application fees. Okay, so if you are interested to apply, you must use this code, save 500 rupees, and utilize them somewhere else. Okay, is everyone clear? Superb. So I think that will be it from my side in this session. You all have been a lovely audience. Thank you all. I will hand it over to Swaroop. Also, for free CS course, there is a form which is available which you can fill, and you can get a free course that can get you started with the fundamentals of computer science. Over to you, Swaroop. Thanks.
Yes, thank you so much, Sitish sir. It was very wonderful session. And yeah, as mentioned, CS course, they can fill the form. There will be a time limit. You have to fill the form so that you will get a mail. You can access that course. And second point, if you want to be the part of Scalar School of Technology, the last intake, so the date is also closing very soon. So I'm sharing the screen also. If you guys can see, you can use this code as mentioned by Sidit sir for getting a 500 rupees waiver on the entrance test. And the dates, I can also show the dates. So the last intakes are 4th August and 7th August for your NSCT entrance examination. And yes, if you are lucky enough and if you pass the NSCT examination, you can be the part of Scalar School of Technology. And yes, hoping to see you soon at the campus. And that is all about this session. I hope you have got a wonderful understanding about programming language and beginner roadmap also. We have also made a lot of videos on our channel, as mentioned by Sitit sir. There is an entire playlist for computer science. You can go and check it out. And yes, overall, this is everything. We can close then. Shedit sir, we can close the session right now then.